One of the simplest practical applications of linked list is in the building of stacks. In general terms, a stack is a type of LIFO structure where LIFO stands for last in, first out. In other words, the last element added is the first to be removed. This is how we set up the linked list. First, we declare a head pointer and a tail pointer. They are both pointers to struct LL node. Now, we call init LL node to create a new LL node and make head point to it. This is the head node, which has a null character in it. Then, we call init LL node again and make tail point to this new node. This is the tail node, which also has a null character in it. Now, make head arrow next point to where tail is pointing to, which is this tail node. The initial list is now set up. Push. We declare a temp pointer, which will be the pointer to the new node. Suppose the user now types a C. This is passed to val. So, we call init LL node to create a new node with C in it and temp points to the new node. Then, we make temp arrow next point to where head arrow next is pointing to. Now, make head arrow next point to where temp is pointing to, which is this new node with C in it. Now, we have finished the first push and return to main. So, we call push again and have a new temp and a new val. Suppose the user pushes a B. The B is now passed to val. So we call init LL node again to create a new node with B in it and temp points to the new node. Then we make temp arrow next point to where head arrow next is pointing to. Now make head arrow next point to the same place as temp, which is this new node with B in it. We have now completed the push and can return to main. Pop. We declare a temp pointer and a car pointer, where the temp pointer will be the pointer to the popped node, and the car pointer will be copied from the head pointer. Val will store the popped value. The first node to be popped will be the one with B in it, because that was the last thing to be pushed into the stack. We need to store the popped value because we will still need to return it after the node has been freed. So, we follow car arrow next arrow key and put that value into val. We point temp at car arrow next so that we can find him to free him later. We want to make the head node skip the old first value, so we make car arrow next point to car arrow next arrow next. So now, you can see we have skipped the original first node on the list with the B's. Because of this, we can now safely free that first node, which is pointed to by temp. Free! Now we have completed the pop and can return to main. If the user now decides to pop again, it will pop the next LL node, which is the one with the C in it. Val will store the popped value. This means that we will now have to store the popped value, so we follow car arrow next arrow key and put that value into val. We point temp at car arrow next so that we can find him to free him later. We want to make the head node skip the current first value of C, so we make car arrow next point to car arrow next, which is the tail node. So the stack is now empty. Because of this, we can now safely free that first node, which is pointed to by temp. Free!